Here's a solution to our problem. So as you know, with the overall strategy, we've got our functions first and then the main down the bottom, even though we're going to do the main first. So that as you know, main's going to get called first, and we're going to put main onto the stack. Now, again, this is empty here because notice in the main, we're not creating any variables. We're not doing anything crazy really. So the main, the least the call gets go ahead and put onto the stack. Then after that, because we're in main, we're going to start going from top to bottom of that function. We're going to go ahead and call F3. So let's jump up to F3, which is actually right here. So F3 is going to see out computer programmers are, and you see the output computer programmers are. You'll also see that F3 is put on the stack, and again, it's empty because there's no variables or stuff like that. But if I'm doing F3, I've done the see out. Now if I scroll down, I have to jump to F1. So when F1 is called, we are adding another item to the stack. Now notice, I'm not done with F3 and I'm not done with main. So think about it. F3 is really not going to be done until F1 is done whatever it needs to do. Main is not going to be done, well, basically till after F3 is completely done, and F3 is waiting for F1. Whew, sounds like a line at the DMV. But anyway, so that's why F1 is there. So we're going to go up to F1, and there goes see out Rich again, and there's Rich being added right there. And geez, when you believe it. Now we've got another call to F2. So F1 is going to wait till F2 is done. So here's F2. Now finally, and now you know why I told you I don't want to see this in your code, because this really spaghetti code you've heard about before, but also this is going to get tougher and tougher to test if we have calls from all over the place instead of one person that might be delegating, or one function that might be delegating most of the load. So we would have to literally trace through the whole thing to find out where the issue is in this type of example. That's why I don't want to see it. Anyway, back to the point. So at F2, we're going to go ahead and add it to the stack here, and then we just see out Rich. Well, actually, we're really just spitting out nerds. And there it is. Now here's the good news, is that F2 is done. There's no more calls after this, so F2 is going to go ahead and die on the vine, as I'll call it, but it gets removed from the top of the stack. That memory is then reused for something else. Now, who called originally F2? Well, F2 was called originally by F1. So we go back to F1, we already see outed the Rich, and we just did F2, so F1 is now done with everything. Now, who called originally F1? That was F3. We see outed, the computer programmers are, we're done with F1. So we're going to start noticing how the stack is starting to collapse, and that's exactly how it should work in all of our applications. Otherwise, we have a memory leak, which is very popular in a lot of games and stuff like that because they don't finish things off. So I can tell you some horror stories. And now main, we're done with F3. We return 0, and then we get rid of the main as well. And then the program closes. The stack has been totally returned back to memory so we can reuse it again.